This is a nice math question. B squared minus B cubed equal to 150. How do we solve for B? B squared minus B cubed minus 150 is equal to 0. So we have B squared minus B cubed minus 150 could be written as 125 plus 25 equal to 0. So B squared minus B cubed minus 125 could be written as 5 to the power of 3. So we have 5 to the power of 3 plus 25 could be written as 5 square equal to 0. Let's proceed further. B square minus B cube minus times 5 cube, that is minus 5 cube, minus times 5 square, that is minus 5 square, equal to 0. At this stage, let us rearrange this equation. So that will be minus 5 square minus B cube minus 5 cube equal to 0. It is very possible I can put these guys in brackets. So I have B square minus 5 square in brackets. To put these two guys in brackets, I need to factor out the negative sign. So that will be minus into B cube plus 5 cube equal to 0. Recall that s square minus y square is equal to s plus y times s minus y. This is a difference of 2 square. Also recall that s cube plus y cube is equal to x plus y times s square minus xy plus y square. This is a sum of two cubes. Take note of these two properties. Very important. Applying this first property to this guy, what do we have? We simply have b plus 5 times b minus 5 minus. Applying this second property to this sum, what do we have? We have b plus 5 times b square minus 5b plus 25 equal to 0. Let's proceed further. You will observe that b plus 5 is common. I can pull it out. So I have b plus 5 into b minus 5 minus this b square minus 5b plus 25 equal to 0. B plus 5 times b minus 5 minus times b squared, that is minus b squared, minus times minus 5b, that is plus 5b, minus times 25, that is minus 25, equal to 0. So we have b plus 5 times minus b squared, b plus 5b, that is 6b, minus 5 minus 25, that is minus 30, equal to 0. This implies that b plus 5 is equal to 0, or minus b squared plus 6b minus 30 is equal to 0. It is obvious from this line, b is equal to minus 5. Let's call this b1. This is the first solution. Now, for this particular equation, let's multiply both sides by minus 1. So that gives b squared minus 6b plus 30 equal to 0. We can solve this quadratic equation using quadratic formula, which says b is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. But to avoid confusion, let's call this b star. So from this equation, a is equals to 1, b is equals to minus 6, and c is equals to 30. Let's proceed further. B star is equal to minus, what is b? B is minus 6 plus or minus square root of b squared, that will be minus 6 all squared minus 4 times a is 1 times c is 30 divided by 2 times 1. So b star is equal to minus times minus 6, that is 6 plus or minus square root of minus 6 all squared is positive 36 minus 4 times 1 times 30, that is 120 divided by 2 times 1, that is simply 2. B star is equal to 6 plus or minus square root of 36 minus 120, that is negative 84 divided by 2. B star is equal to 6 plus or minus square root of minus 84 could be written as square root of 84 times square root of negative 1 divided by 2. B star is equal to 6 plus or minus. Recall that from the complex number, square root of minus 1 is equal to I. So we have square root of 84 I divided by 2. B star is equal to 6 plus or minus square root of 84 can also be written as square root of 4 times square root of 21. This becomes square root of 4 times square root of 21 times I divided by 2. B star is now equal to 6 plus or minus. What is square root of 4? That is 2 times square root of 21 times I divided by 2. It is possible I can factor out 2 from this numerator. So I have 2 into 3 plus or minus square root of 21I divided by 2. Clearly, 2 cancels 2. We are left with B star equal to 3 plus or minus square root of 21I. But don't forget, but B star is equal to B. So we have B equal to 3 plus or minus square root of 21I. Therefore, all the solutions that we have for this algebra problem are: the first one is B1 is equal to minus 5. From this, we can obtain our B2. B2 is equal to 3 plus square root of 21I, and B3 is equal to 3 minus square root of 21I. These are the three solutions for this algebra problem. That's it. Thanks for watching.